Questions 11 through 10 on the 2005 Grade 11 Fermat Math Contest. Rectangle ABCD is made up of 6 squares. The areas of the 2 of the squares are shown. The perimeter of rectangle ABCD in centimeters is. So if this square has an area of 25, that basically means that each side is 5. That's how you get an area of 25 for a square. And very similarly, if that is 36 in terms of the area, those sides would be 6. So this is really just a question of filling in all the remaining sides. So if from here to here is 6, and from here to here is 5, that means this little guy here is 1. All right? And in a very similar way, we can figure out all the other sides. If from here to here is 5, and this is a square, since they're all squares, then the remaining is 4. And therefore this is 4, and this is 4, this is 4, and this is 4. Since those are squares, all the sides are the same. So that means this whole length is 5 plus 4 plus 4, which is 13. And this whole length is 5 plus 6, which is 11. So the perimeter is going to be 11 plus 13 plus 11 plus 13, which is 48. So the answer to number 11 is E. Starting with the 2 in the center, the number 2005 can be formed by moving from circle to circle only if the 2 circles are touching. How many different paths can be followed to form 2005? So we've got this diagram, and the rules are that you're going to try to find a path to spell out, I guess, 2005. So if you start with this 2, you go here, and then you go here, and then you go here, for example. That makes 2005. So they want you to figure out how many different paths are there. Now, the simplest way is to just do this one step at a time. So from the 2, there's only one choice in terms of what's the next digit, right? It's a 0 if you want to make 2005. But how many zeros do we have? We've got 6 of them all the way around. So each of those zeros is what I'll concentrate on, and hopefully we can see some sort of a pattern. So first, let's just start with that 0 right there. Okay? Now, when I go from 2 to that 0, I've got the first 2 digits of 2005, but I've still got to get another 0 and another 5. So to get another 0, I can either go this way or this way. There's only 2 options. So I'll draw that over here, this way or that way. Now, once I get to that next 0, I've got to get a 5. So if I'm here, the only way is either here, here, or here. I can only go to a circle that's touching. Okay, let's draw those in here. A 5, and a 5, like that. All right. Now, let's say I went here. From that 0, which I have drawn here, how can I get to a 5? I can either go this 5, that 5, or that 5. So that's this 5, that 5, or that 5. Okay? And that's it. Those are the total paths for just this particular 0 right there. And how many did I get? Well, I got 1, 2, 3, 4, 5, 6. 6 paths for this 0. Now, the good news in this question is that if you do the exact same thing with any of the other zeros, you will also get 6 paths. So since there are 6 zeros, each of them lead to 6 paths, the total number of paths is 6 times 6, which is 36. So number 12, the answer is A. A circle is drawn so that no part of it lies outside a regular hexagon. if such a circle does not touch all 6 sides of the hexagon, what is the maximum number of sides that it could touch? So first, let's draw a hexagon, a regular hexagon. So here we go. Here's a regular hexagon. Now let's talk about this question. The first thing they tell you is that the circle that is drawn inside, no part of it lies outside of it, right? So here's one example. No part of this circle lies outside the hexagon. Now, how many of the sides does this circle touch? Well, 0, okay? But 0 is not one of our answer choices, but I just wanted to show you that. How about if I draw a circle like this? It touches one of the sides, and therefore 1 is possible. But let's see if we can get any others. How about if you draw a circle that touches 2 sides? Is that possible? And the answer is yes. Here's an example of that. It touches 2 sides. So 2 is also possible as an answer. Okay, well, the maximum number of sides is what we're looking for. So far we've got 2. Can we get more? Can we get a situation where a circle drawn touches 3 sides and only 3 sides? And the answer to that question is no. If a circle touches 3 sides, it will touch the other 3 sides also. So, since if you have a circle that touches 3 sides of the regular hexagon, it will touch all 6 sides, the maximum is just 2. That's the only way that you can get a circle inside a hexagon touching the sides. You can either get 0 sides that it touches, 1 side that it touches, or 2 sides. Once you get to 3, it touches all 6 sides, and they tell you in the question that the circle does not touch all 6 sides. So the maximum we can get is 2. Number 13, the answer is B. The weight of a lioness is 6 times the weight of her female cub and 4 times the weight of her male cub. If the difference between the weights of the male and female cub is 14 kg, the weight of the lioness in kg is. A lioness is 6 times the cub that is female. The lioness is 4 times the weight of the cub that is male. And they tell you the difference between the weights of the cubs is 14. So that these are the mathematical equations. All right, I guess we're substituting them in. So Cm is going to be L over 4, directly from this guy. Cf is L over 6, and that is equal to 14. So doing the subtraction of these fractions, get 24 as a common denominator. 6L minus 4L is equal to 14. And that means 2L is equal to 14 times 24, if you cross multiply. So 2L is equal to 336. And therefore L is equal to 168. So number 14, the answer is C. If x minus 4 times 5x plus 2 is equal to 0, then 2 possible values of 5x plus 2 are x minus 4, 5x plus 2 is equal to 0. So solving, this is all already in factored format. So that means x minus 4 is equal to 0, which gives you x equal to 4, or 5x plus 2 is equal to 0, which would give you x is equal to minus 2 over 5. Those are the 2 possible values for x to make this equation work. And they want the 2 possible values for 5x plus 2. All right? 5x plus 2, using the first value of x equal to 4, would be 5 times 4 plus 2, which is 22. And then 5x plus 2 using the second value, well, that one you probably can figure out in your head, but I'll just do it, no problem. minus 2 plus 2, and that is 0. So our two values are 22 and 0. And therefore, number 15, the answer is C. In the diagram, C1 and C2 each have center 0. The area of the shaded region is. The area of the shaded region, AS. And that's obviously going to be the big circle, pi r squared, minus the small circle, pi small r squared, like that. Now we have to figure out what is the value of big R and little r. Well, the small r, which is right here, this distance, we can figure out using Pythagoras, and they pretty much spelled it out for us. They've given you a right triangle, they've told you it's a right triangle, they've given you the sides. So 1 plus 1, or 1 squared plus 1 squared is r squared using Pythagoras. So therefore r is equal to root 2. Okay? So that's small r. Now the big R is going to be basically 2 of those small r's, because this is r also. So the big R is equal to 2 of the small r's, so that's 2 root 2. Okay? And that's it. That's all we need. So pi, I'll factor out the pi. R squared is 2 root 2 all squared minus small r squared, which is root 2 squared. And this looks like 2 root 2 squared is 4 times 2, which is 8. And then root 2 squared is 2. So that's 8 minus 2, which is 6, and therefore this is 6 pi. So number 16, the answer is D. A cylinder with radius 2 centimeters and height 8 centimeters is full of water. A second cylinder of radius 4 and height 8 is empty. If all of the water is poured from the first cylinder into the second cylinder, the depth of the water in the second cylinder will be. Here are our two cylinders. The first one has a radius of 2 and a height of 8, as they state in the question. The second one has a radius of 4, and its height is also 8. And the first one is the one that they fill with water. So all of this is water. And the volume, therefore, if you look at the volume formula for cylinders, is pi r squared, which is the shape of the top. It's a circle, right? If you look at it from a bird's eye view, if you look at it from that view, it'll be a circle. And that's essentially the area of a circle. And you multiply that by the height. So it's a fairly easy formula to remember. And using our numbers, we got pi 2 squared times 8. And that's going to be 4 times 8, so that's 32 pi. And then what they do is they pour all that water into here. So it's going to come up to a certain level. I don't know, maybe up to here, say. And they want you to figure out this height. That height right there. Okay, no problem. Again, exact same. Volume is pi r squared times height. Our volume is 32 pi. And then let's see what else we know. R, the big R, is 4. And then be careful, the h is what we have to figure out, right? The total height of that cylinder is 8, but the volume of the water only goes up to a certain level. So that's why I denoted it small h right there. Okay, this is the equation we have to figure out. So the pi's cancel, and you're just left with 32 is equal to 16h, and therefore h is equal to 2. So number 17, the answer is B. A test has 10 questions. Points are awarded as follows. Each correct answer is worth 3 points. Each unanswered question is worth 1 point. Each incorrect answer is worth 0 points. A total score that is not possible is. This question reminds me of a scenario. I knew a student who scored the highest score in all of Canada on one of these Fermat contests a few years ago. But when he got his score back, it was 145, right, out of 150. And he couldn't understand how did he get 145, because he knew all the answers. He knew, when he handed in his paper that he scored perfect. He was convinced of it. But when he got his score back, he got 145 out of 150. And for the longest time, he couldn't understand how did that happen. Because if you miss one of the hardest questions, the last 5, your score would be 144. If you answer it blank, or if you answer it incorrectly, your score would be 142. So he racked his brain, and finally he realized that it was one of the first few questions, the first 10, that he got wrong by accidentally circling the wrong answer. And if you do that, it costs you 5 points. So as you can imagine, he was quite heartbroken. So this question actually reminds me of that. It's very similar. This time they've got 10 questions, and they've given you a very similar kind of point system. Which of the following scores is not possible? Okay. Well, I kind of immediately, by looking at the answer choices, I can tell, just because I've done so many of these math contests, but I'll explain it. Let's say you get all 10 correct, right? Well, you'd get 10 times 3 points for each correct. That's a 30-point total. Let's say you have 9 correct, and you have one question that you left unanswered. That would mean you'd get 9 times 3 points for the ones you got correct, plus 1 point for that one question you left unanswered. This is a score of 28. All right? How about you have 9 correct and one question that you got wrong? Well, you'd have again 9 times 3, but for the wrong question, you won't get any points. You get 0 times 1, and that's 27. And then so on down, right? 8 correct, 1 unanswered, and so on. Notice there's one score that's not possible. It is 29. There's no way of getting 29 with this scoring system. So number 18, the answer is E. Sam bicycles at 16 kilometers per hour and Chris bicycles at 24 kilometers per hour. At noon, Sam is 1 kilometer north of Chris, and each begins to ride north. How many minutes will it take Chris to catch Sam? Let's say they are here, and they're both going north, right? They're both going north like that. And at this point, this is what they talk about in the question, that's where Sam is, and that's where Chris is. And this is 1 kilometer. And that is the scenario, I guess, at noon. Okay? I don't know if noon is important in the question, but... And then eventually, Sam gets to this point, and then Chris catches up with him. So I'll write Chris here. Chris and Sam eventually get to the same point right there. Now, the distance from here to here, I don't know, so I'll just call it X. Okay? So that's the setup. The formula, of course, speed is equal to distance over time. Very famous formula. And any other combination of this will also be true. For example, distance over speed is equal to time, and so on. Now, when Chris goes from here to here, that is the exact same amount of time that Sam goes from, Sam, his name is Sam, goes from here to there. So that means those two times are the same. The time for Sam and the time for Chris. Okay? Chris going from there to there, and Sam going from there to there. Okay? So times are the same. So let's use this formula. So that would mean the distance for Sam divided by the speed for Sam. And the other side would become the distance for Chris divided by the speed for Chris. All right? Distance for Sam from here to here is X. We don't know, so that's why I call it X. His speed is 16 kilometers per hour. Distance for Chris from there to there is 1 plus X, and his speed is 24. So there you go. That's the mathematical formula. 24x is equal to 16 plus 16x. This is 8x is equal to 16. And that gives me x is equal to 2. 2 what? Well, it's 2 kilometers. Okay? All right. Well, what are we trying to figure out in the question? How many minutes will it take Chris to catch Sam? So basically, we're trying to figure out the time that it takes Chris to go from here to there. Okay, no problem. We can use this formula once again. Time is equal to distance over speed. Well, the distance is 1 plus x, and the speed for Chris is 24. And this looks like 3 over 24 since x is equal to 2, and that is 1 over 8. Now this time is in hours. Now we want to figure out how many minutes. Oh, no problem. 1/8 of an hour is essentially 60 over 8 minutes. And that is equal to 7.5 minutes. So number 19, the answer is D. In triangle ABC, if AB equals AC equals x plus 1, and BC is equal to 2x minus 2, where x is greater than 1, then the area of the triangle is always equal to. Let's draw an equilateral triangle, because that's what this is. There we go, right? Because they've told you that AB is equal to AC. So if I label this, I will call this A, I'll call this B, and I'll call this C. And they tell me that AB is x plus 1, and AC is the same, x plus 1, and BC down here is 2x minus 2, like that. Now what I'm going to do is drop a perpendicular from A down to the base, like that. Now, this is of course going to be a right angle. And in an isosceles triangle, the rule is that if you do that, it chops the base into halves. You basically cut the base into half. So this is 2x minus 2, the whole thing, BC. So 2x minus 2 is actually 2 factored out x minus 1. So that means each of these is x minus 1, like that. Okay? And now I need to figure out this height here. And I can easily do that using Pythagoras. So that means h squared plus x minus 1 squared is equal to x plus 1 squared, like that. Let's do the math here. We got h squared, plus x squared minus 2x plus 1 is equal to x squared plus 2x plus 1. Let's see, a few things will cancel. The x squareds go, the 1's go, and then I can put the 2x on the other side, and it gives me 4x, like that. And then take the square root, and we get 2 root x. And there we go. We can now figure out the area. Area of this triangle. 1/2 base times height. The base is this guy right here. Let me factor out that 2 there. And then the height is h, well obviously, but h we just figured out was 2 root x, like that. And there you go. Let's see if we can simplify this. The 2's go, so all we're left with is 2x minus 1 root x. And that would be, for number 20, choice E.